Hello students, Ms. Slyman here with your notes about graphing tangent. So if we think about tangent, if we think about the theta value here and the tangent of this theta value, well, it's the opposite side over the adjacent side, which of course we know corresponds to the x value and the y value. So if we think about this, tan is opposite over adjacent, but also for any graph that also goes through the origin, any line that goes through the origin, the slope is also the rise over the run. So tangent we can think of as the slope of the terminal side. So if we start at the angle of 0, then our slope is 0. So now we're graphing tan theta on the axis. If we think about pi over 4, then our slope is root 2 over 2 over root 2 over 2, which is 1. So at pi over 4, the tan value is 1. So let's make every 2 a pi over 4. And let's count this as a 1. When I get up to pi over 2, the slope is infinite. That means my tan graph has an asymptote. And we know at pi over 3, our slope was root 3, so it's just getting bigger and bigger. So we're following up this way towards infinity. Now, as we come this way, when we have 3 pi over 4, that slope is negative 1. When I have over at negative pi, then I have a slope of 0. When I'm down at 5 pi over 4, then I have a slope of positive 1. So 5 pi over 4, we get positive 1. And then if I get all the way around to 2 pi, at 3 pi over 2, I come here next, and I have another infinite slope. So 1, 2. Obviously, I should have thought about this a bit more to fit it. So negative infinity. Let's make this a bit better. And then we curve up towards positive infinity. All right, let me draw that whole curve a little bit better. So tangent goes wow, that looks very terrible. And we continue. So every interval of pi over 2, so negative pi over 2, that's when I'm dividing by 0 or when I have an infinite slope of a line. Is that far enough? Maybe that was not far enough. No, it's not a full period. So this one, we've got our negative 1 down there, heading towards infinity. 1, 0. Continuing down. So notice here's my full period. It goes from negative pi over 2 to pi over 2. So a period is 1 pi. So I'm going to fill that in first. Period is 1 pi. My range, we're going negative to positive, so y element of reals. And my amplitude doesn't exist. I go from negative infinity to infinity. So not applicable. And now let's think of domain. Domain exists for every value of x except for where I'm at pi over 2, 3 pi over 2, this one over here is 3 pi over 2, negative pi over 2, negative 3 pi over 2. So it's the odd values of pi over 2. Well, I can think of odd numbers as being 2k, either plus 1 or minus 1, where k is an integer. So take a number double, it makes it even. Add 1 or subtract 1 makes it odd. So x element of reals, x not equal 2k plus 1 or 2k minus 1 times pi over 2. So odd numbers over 2. That's where we have all of our asymptotes. Okay, so let's think about how this applies with transformations in the next video.